Here is another example where the question is asking you to calculate the enthalpy value of a bond. The question will give you the enthalpy of the reaction. So it's the same process. You are going to need to know that the enthalpy of a reaction is the sum of the bonds broken minus the sum of the bonds formed. It's always worth pointing out, show your working, make it logically set out. If you don't show your working, you get no marks. Your final answer must have units and you need 3 sig fig. Okay, so here's the question. Methane gas and ammonia gas react together to form hydrogen cyanide and hydrogen gas. And they've told us the enthalpy of this reaction is 213 kilojoules per mole. So what we're going to be doing is working out the average bond enthalpy of the carbon to nitrogen bond using the values that they've given us. Step 1, draw out the structures. It makes it so much easier when you can see the bonds that you're actually breaking and making. So here you've got your methane structure, your ammonia structure. This is your hydrogen cyanide here, and notice it's a triple bond. And then you've got 3 hydrogen gas molecules. Set it out like we always set out the simple ones, and that is with the bonds that need to be broken. So in this instance, you've got 4 carbon-hydrogen bonds that need to be broken and 3 nitrogen-hydrogen bonds. The bonds we're making is a hydrogen-carbon bond, a carbon-nitrogen, and then these 3 hydrogen-hydrogen bonds. Let's get the values. So using the values in the table, we can work out the subtotal there for the bonds broken. 4 lots of 413 and 3 lots of 391. So you've got your subtotal for bonds broken being 2,825. Now for the bonds formed, 3 hydrogens, 1 of the hydrogen-carbon bond, and then we've got this bond that we don't have the value for. And so this time I'm using an X to represent the fact that I don't know what this bond energy is. So the subtotal on the bonds formed side is 1,721 plus this value X. Next step, let's bring in the equation that you've got to know, so bonds broken minus bonds formed. And we do have the enthalpy for the reaction, so we're going to put that value in, which is 213. And that is equal to the subtotal for the bonds broken minus the subtotal for the bonds formed. Next step is to make this and solve it for the value of X. So to put X on the other side of the equal sign, notice that it's minus the X because the X is in the brackets there and this minus is in front. So that's why that X is a positive on the left hand side. And to put the 213 on the other side of the equal sign, we need to subtract 213, which is why it's minus 213 for the enthalpy value. And then it's just the plus 2825 minus the 1721. So in your calculator, get yourself the value, and X is 891 kilojoules per mole. Whoops, I shouldn't have used a question mark, it is actually X, but you know what I'm talking about. The question doesn't finish there. It's important that you give your answer full, and so while X is representing the carbon triple bond nitrogen, it's important you finish your answer by saying the bond enthalpy for the carbon triple bond nitrogen is plus 891 kilojoules per mole. Notice I've got my units in, I've got my 3 sig fig, and I've got my plus symbol, and all bond values, bond enthalpy values, are quoted for bond breaking, so they're always positive values. Okay, so that is the trickier type of question where you're finding a bond value, and we've done 2 examples, so fingers crossed if you get one in your exam you know exactly what you're doing now.